sometimes see this in the road, no? Yan ay magbangga. Okay? Ay magbangga. Okay. So, this problem, morning nga problem ato sa buntaon, no? And we are going to apply the principle of impulse and momentum. Okay. So the problem read like this. 6,000 kilogram SUV traveling at a speed of 10 meter per second collides with a 4,000 kilogram compact automobile which is stopped at a stoplight. Okay. The coefficient of restitution is 0.7. The impact occurs over 0.3 seconds. What is the average impulse force applied to this vehicle? To these vehicles, no? What is the average impulse force applied to these vehicles? Okay, so ang gibuhat na mo ani sa kuan, sa other section kita sa na mo ning doing, no? So first we have ako sa tiguan sila ni. First we have kuan, we have a car na nag-stop, no? Nag-stop na siya. Nag-stop na siya. So atong paano itong hit at ibali, no? Sa kuan. So, primero, doon ay car. Okay. Primero na ay car. Ano ba rin yun? Sila lang. Okay, so first do the car na compact car nga nag-stop, no? 4,000 kilograms. So nag-stop siya. So we call this as a big two, no? Because this is 0.2. Okay? And then not farther from it is you have a vehicle na SUV, no? Nag-run of 10 meter per second. The weight is 6,000. So I'm gonna took arrow like that, no? So it's going to hit the vehicle, no? The vehicle. So if we consider this as one, no? If we consider this as one, okay, we consider that as one. Yeah, one. So then this one will be two. Will be 2.2. Okay. So, a 6,000 kilogram SUV running at 10 meter per second is about to hit the car. It stopped at stoplight. So, B at 0.2 is 0, while B at 1 is 10. Then M at 1, we will consider this as M1. M1. Ano ba siya M1? M1. Subscript ka. Then himon taning into. So the mass at 2 is 4,000 kilogram. Okay. This one is trying to hit that one. So what happened? No, what happened at the impact? So what happened at the impact? So there might be question: what happened? What happened during the impact? During the impact. Of course, siguro wala namatay, assuming nagka-seatbelt sila tanan, no? So, we are talking about the motion of the two bodies, no? The SUV 1 and the car number 2. What happened during the impact? Or after the impact? After na lang. After the impact. After the impact. Okay. So, first is by conservation of linear momentum. Okay? So, conservation of linear momentum is like this. Okay. The law of momentum conservation can be stated as follows. For a collision occurring between object 1 and object 2 in an isolated system, the total momentum of the two objects before the collision is equal to the total momentum of the two objects after collision. Okay, so this is basically the law of conservation of momentum. So we will assign object 1 as car number 1 and object number 2 as car number 2. Okay, so this is a collision of two objects. No? Here we have car number 1, we have car number 2 as the objects here. Okay, so the equation here, this is the momentum of the two objects. So if we are going to recall the what is momentum, momentum is just the mass multiplied by its velocity. So it's a vector, no? That is the object's momentum. So here we have the two objects. So our formula, according to the law of conservation of momentum, on the left hand of the equation is the momentum of the two objects. So object number 1 weighing 6,000 kilos and the velocity is 10. So the momentum then is 6,000 times 10. Then it says here, the momentum of two objects. So 6,000 times 10 is just for one car, while the other car is 4,000 times 0. Why you multiply it by 0? Because the car is not running. So there's no momentum, no? Wala kay momentum kung wala ka magdagan. So momentum. Okay, so the total momentum of the two objects collected nila is equal to 60,000. That is only for one car. The second car has no momentum. Now, on the other side of the equation, is equal to the total momentum of the two objects after the collision. After the collision, we do not know what is the speed of the car number 1 with the car number 1. Muhunong ba siya? O muhunong ba siya? Just like mabanggaan ka sa laing nga tao kung sabi may tabo. No? Kung sabi may tabo nimo, naghunong gyapon ka o matulod ba ka gamay? Yan na, no? So, kung di sa nato sulbo ng problem atong imagine nung sa may tabo, siyempre pagbangga niya mulagpot ning car nga number 2. Nya kini siya mas slow down siya tungod kay nakabangga siya po nagyapon siya movement. But using a 10 meter per second, I think dili na, no? Medyo minus sigit sa siguro, no? Ang iyang velocity kay nakabangga gud siya, no? So while ang number 2 nga car, dili sa di siya maghulong lang, no? So may tabuan niya lagpot ni siya, no? Just like kung ikaw sa babanggaan og dako nga tao, wag malagpot ka, no? Like for example, nadula mo basketball niya, imo siyang giblakan, niya kusog ang dagan. Tungod sa iyang timbang niya kusog ang dagan, so ang product atong duha mo to siyang gitawag og momentum. Nya ikaw nag-alik nag-block ka sa iyang agianan, so mas ma-absorb nimo iyang momentum so muna nga mulagpot ka, no? So doon na sa kay velocity. So in other words, the total momentum of the two objects after the collision is still equal to the mass of its car, but we do not know the velocity after that, just after the collision. So we assign V1 as the velocity of the 6,000 kilogram car just after the collision, and V2 for the car number 2 just after the collision. So this is as far as principle of law of conservation is concerned, this is the equation that we can make. Okay? Now, what is this 60 plus 6B1 plus 4B2? Parehas po na sa equation, ako lang ipag-erase ang mga tulo ka zero sa kada term. Erase na kung tulo ka zero din tulo ka zero, tulo ka zero, tulo ka zero. Okay. Tanan man sila, doon ay tulo ka zero. So, it will become like this. The equation is like that. Okay. So, second is, we have another ingon sa problem is the coefficient of restitution is 0.7. So we have here coefficient of restitution. Coefficient of restitution. Okay. So, or that is equals to CR equals to 0.7 CR. CR is a subscript. Ay, pumili siya kung okay, so it's just subscript me. Okay, siya. Oh, coefficient of restitution siya. Why we say coefficient of restitution? Tungod kay naging man ang problem na the coefficient of restitution is 0.7. Okay. Now we will see what is coefficient of restitution. No? Coefficient of restitution. So maybe we'll define what is restitution. No? Para maklaro na to. Restitution. Okay, na pala eh. Okay, we'll define this one. Yung tao restitution. What is restitution? Restitution. Restitution. Meaning restitution meaning. An act of restoring or a condition of being restored. A restoration of something to its rightful power. Okay. So, muna meaning sa restitution, no? So, what is another word for restitution? Recompense and means compensation, requital, satisfaction, retainment. So, restitution, an act of restoring condition of being restored. No? So, pwedeng kopyahon. No? Balik sa mga topic. Restitution, meaning. Restitution. Okay. Restitution. Restitution. Meaning. Okay. Meaning. Yeah. It means restitution. Yes, money. An act of restoring a condition of being restored. So, CR is equals to 0.7. Okay. Now, nawala man. Okay, so we will continue. So, if the coefficient of restitution is 0.7, then we'll go back. We'll go to the definition of coefficient of restitution. Coefficient of restitution. Okay. Coefficient of restitution. So CR. Actually, the C sub R is already given in the problem here. Okay. But we will just solve back what is the formula of coefficient of restitution. The formula of the coefficient of restitution is simple, no? It is just a division of two velocities. So actually this is minus, nani say minus dia, nani minus. So V sub B minus BA over U sub A minus UB. Okay, where BA is the final velocity of an object A after the impact. So, and V sub B is the final velocity of object B after impact over, okay, so let's talk about the denominator. The denominator is UE minus UB, no? So UE is the initial velocity of object A before impact and is the initial velocity, UB is the initial velocity before impact. So we will find that, no? So if BA is the final velocity after impact, so we call this as B1. And then BB, BB, according to the Phoenix, is the final velocity of object B after impact. Object B is the car number 2, so we call that B2. Okay, so we will put this into subscript. This one is the subscript. This one is also subscript. This one is also subscript. Okay. Now, how about U? Okay. UA, initial velocity of object E before impact. So that is U1, V1, that's the initial velocity of object 1, no? Car number 1, so that's 10 meter per second. And here we have UB is equal to the initial velocity of object B before impact, and that is 0. Okay, we are referring to car number 2, which is stopping at the stop light. Okay, so that's it. Okay, so we have to substitute it here, no? So if your CR is 0.7, so you will have 0.7. Your equation will become substituting to the equation of CR. This is a subscript. So this is the substitution, and since CR is 0.7, so we'll substitute that, and that is equal to, we'll just put that in a parenthesis divided by inside the parenthesis. Okay. So the numerator is, you have BB minus BA, so you will have B2 minus B1. Okay, which we do not know as of this moment. Okay, and gihatag na velocities are the initial velocities man, no? The initial velocities. So at time 0, while the car is still here, wala pa nakabangga, the car number 1 is running at 10 meter per second, while car number 2 is stopping. So wa siya kabalo nga banggaan ba siya, no? Kasi ato say magkalikod ta, wa ta kabalo nga na di mo bangga sa ato, no? So makalingi rin ta sa mga tawanan ng bangga mo. So yan na. So the denominator will become UA, initial velocity of the car A, so that will become 10 minus 0. Or this is just equal to V2 minus V1 divided by 10. Okay, so it becomes like that. Okay, good. Okay, now you have two equations actually, no? From the coefficients of restitution, and the other one derived from the principle of momentum, conservation of momentum. So you need actually two equations because you have two unknowns, B1 and B2. No? So this one, we use this one. Okay, we use this equation. Okay, so you have this at the okay, so now you substitute, so you will have, you simplify this, you will have B2, if we simplify this, we have B2 minus B1 is equal to 7, no? Because 10 times 0.7 is 7. We might remove the parentheses. So this is the equation. Okay? So if we substitute, if we change this. Mhm. Sayop ni UB minus UE ni siya. No? This is UB minus UA actually. So, ini siya is 0 minus 10 ni siya. Is 0 minus 10. So, it's like that, no? 0 minus 10. Or you can make that positive by just reversing this. Okay, so 0 minus 10. So, kaya nga naman, B man nilag-una din niya, minus BA, dapat B sa nilag-una, minus UA. So, nasayop ni. Sayop na siya. So, in that case, you have B1 minus B2. So, here you have B1 minus B2 equals 7. Now, okay, so we will have an equation for B2. So B2 is V1 minus 7. So, muna siya i-equation. Okay. So, if this B2 minus equals to B1 minus 7 is coming from the equation of coefficient of restitution. Okay. So, the next to that is we substitute B2 into the equation formulated by law of momentum conservation. So, we have a simplified equation here in terms of 60 equals to 6B1 minus 4B2. So what happened is you will have this. So substituting B2 to equation 1. Equation 1. Ito na siya tawag na equation 2. Equation 2. Kini siya tawag na ito siya equation 1. Equation 1. Okay, equation 2 and equation 1. Okay. So, substituting B2 into equation 1, we have this, no? So, B1 minus 7, so B2 will be with B1 minus 7, so it becomes like that. So, we will have 60 equals to 6B1 minus 28 plus 4B1. Okay, we can add 2B1 because they have the same coefficient. So, 4 plus 6 equals B1. Then, if we transfer negative 28 to the other side, it will become positive. So, you have 60 plus 28 equals to 10 B1. So, B1 is 8.8 meter per second. Okay. Mao na ang B1 nga 10 meter per second, pagka magbangga niya, nahimo na lang siya 8.8. Mahinay siya, no? Kaya nga naman, nakabangga man siya, no? Even without brake, wala, considering nga wala siya nag-apply ng brake, no? Ang yang 10 meter per second na-disturb, nahimo na lang 8.8 meter per second. Okay? So, just like some billiard ball na imong i-push sa kuan yung tako. Pag magbunal mo sa billiard ball, nidagan ang puti nga bola, pag igo niya at a certain speed. So pag igo niya sa other nga ball, dunay disturbance. So medyo dunay reduction sa ang speed. Okay. While katulad bully ang naigo, nidagan sa no? Yan ano siya. So iyang gibalhin ang energy sa isa ka bola. So here, ang iyang energy, iyang kinetic energy is balhin niya ang uban sa car nga naghulong nga yung nabanggaan. So, ang car nga naghulong nga nabanggaan, doon ang sa velocity. And if B1 is 8.8, we'll go back to the equation 2. No? So, substituting V1 to equation 2, so, okay, buwan naman yung B1, tanaw ni mo pila velocity. So, B1, dito is 1.8 meter per second. So, mo na ang hitabo. Okay? Mo na ang hitabo. Okay. Now, actually, if we are going to answer what happened after the impact, so we see that car number 1, car 1 is moving 8.8 meter per second, while car 2 is moving. So, kung atong what happened after the impact, moving at 1.8. Huh? 1.8. Oh yeah, B1 minus 7, 1.8. 1.8. Ito, moving at 1.8 meter per second. So, after the collision, after the impact, no, ang car number 1 is moving at 8.8, while car number 2 is moving at 1.8 meter per second. So, that is what happened. But the problem asks us also, in fact, that's what really the problem is asking, what is the average impulse force applied to this vehicle? So, what is the impulse force? Okay? So, meaning our problem does not end knowing the velocities of the car, but the impulse force. So, by definition of impulse force, that is equal to mass of 2 times V2 times delta T. No? So, manang hitabo niya. So, times delta T. So, delta T as given in the problem is 0.3 second, and mass number 2 is 4,000, and B2 is 1.8 meter per second. So, what happened is that if you apply that, you have an impulse force equals to 4,000 times 1.8 divided by 0.3, which is 24,000. The unit of mass is kilogram, and the unit of velocity is meter per second. The coefficient has no unit because coefficient ba na siya. So, ang resulta is 24,000 kilogram meter per second. But, ining kilogram meter per second, unsam ni siya kung ato ni siya ang ibalhin to Newton. So, Newton gini siya, no? Okay, Newton is equals to kilogram meter per second man. So, that's 24,000 Newton. That is the impulse force during the collision. Average impulse force during the collision. Okay, so, that's problem number, that's the answer of the problem. No? That's the answer of the problem. Okay, so I will see this. That's so what happened, class, is this morning we solved problem in dynamics of rigid bodies using principle of impulse and momentum. So what we did is we define what is impulse, then we define what is momentum, and then we focus our attention to the problem. So it's about two objects that are colliding. Okay. So the situation is that there is a given data before the collision, and the unknown is what will happen after the collision. Okay. So before the collision, the other object is running at 10 meter per second, which is car number 1. Ang iyang mass given gihapon, while car number 2 is at rest because it is stuck in the stoplight. Now, wa siya kabalo, mabanggaan rin siya. No? So, ang car number 1, wasan siya nakabantay, nga naday car sa tubangan. So, could be na nalipat siya, no? So, wag gali siya ka-break. So, assuming wala siya ka-break, so, gihimo niya ng break ang car number 2 lang, what will happen after the impact, no? And also another given is the coefficient of institution, and then the problem is what is the impulse, no, force during the collision. Okay? So once the car collided, so the two car will be still in motion, no? But we do not know what is the velocity of each car after the collision. That's why we solve B2 and B1 to be 8.8 and 1.8 meter per second respectively. Okay, and the impulse force also. Okay, so using the equation. So that's it, class. Now, okay, sa mga latecomers, I announce that we will have a quiz next Saturday. No? So the quiz, still multiple choice, will be maximum of 15 questions. No? So still it's a mathematical because you need to compute. And then the topic, the coverage of the topic, since it involves calculation, it will be work and energy method in solving problems of dynamics of structure. So, muna na siya class. Okay, so do you have any question? Yeah, I think I will start to now. No? I will start lecturing. No? So, we will, okay na ito akong nahatag. No? Sa example of kanda yun ang announcement. No? Na mag-exam pa. No? Okay. So, do you have any question, class?
Apil ni sa next week, sir. Sa atong
Wala pa. Bago pa man work and energy lang. Okay. Maximum 15 questions naman. Ako yung paano. Multiple choice. Maybe with a few turcles. Yan.
Sige, sir. Thank you.
Okay. Any other one? Question? So, diyan ko nga, so, kung ilan problem, no? We'll just solve next meeting na lang. No? Anyway, halos naman sila ka ng topic ang na-discuss mo. We discuss Newton's law, we discuss work and energy, impulse and momentum. So, knowing all those principles, you can tackle already problem in dynamics of rigid bodies. So whatever the situation, because you know three cures. One is Newton law of inertia, the Newton second law. The mass times acceleration is a very powerful tool solving dynamics problem. The principle of work and energy method also is a powerful tool for solving situation that involves body that constitute work and energy. Also, if you are into forensic, no? Collision, so if you are in the insurance company, you can use this equation about impulse and momentum, collision purposes. In the law of traffic enforcing, you can use work and energy to determine what is the initial speed of the car by just looking at the skid mark of the car. Okay, so without asking the driver what is your speed, so of course you will say I'm just running very slow. Then why is the skid mark longer? So the driver estimate may not be accurate. So, but if you use the law of work and energy, it will always result into an accurate solution. Okay, so that's the class, no? Okay, so hindi lang siguro tama, no? Just be prepared next meeting. So, Mahuman na ni 1 hour siguro ang exam, so you still have more time to do with other one, whatever you want to do. Okay, class?